Good evening and good day, you guys. I'm making a video today on how to calculate the natural increase rate and doubling time. I've had a lot of requests on how to do this, so we're going to go over it real quick and see if we can't help you figure it out. So, how to calculate natural increase rate and doubling time. So the first thing we're going to have to do is fill out the crude birth rate and crude death rate in the sheet. All right, so what we're going to do is we're going to fill out this crude death rate and crude birth rate. So if we look here, we have our world population data sheet open on one side and we have the assignment open on the other. And I'm going to make this a little bit smaller so you can see this. So the first thing we're going to do is we're going to find China. And so we're going to do a Control F and find China, and we're going to type it in. All right, and then we're going to look for where it says China on this chart. Okay, that one says excluding China. All right, here's China. So we're going to zoom in. All right, we're going to make that bigger. Okay, so we just need the birth rates and the death rates. So this is right here. So we're going to go down to China and we're going to put this in. They have 10 for the birth rate and 7 for the death rate. So for natural increase rate, we'll come back to that in a minute. So right now we're just doing the birth rates and the death rates. So then I want to go to India and find out India's total. India's right here, and it's 20 and 6. Right there, 20 and 6. Okay. So we're going to put 20 and 6 in here. All right, then we're going to find Iraq. All right, so there's Iran. So we need to find Iraq. All right, Iraq is right here. They have, like if you're in this one, life expectancy, you don't want to go to that page. You want to go to the next one. All right, so here we are at Iraq. And they have 27 and 4. And then we want to go see Kazakhstan, which is 21 and 7. Again, I'm getting the number from these first, the second and third column here, and right here, and right here. Okay, so then Laos is a little further away, so I'm going to type it in. And it's going to show me where Laos is. And I can see that for Laos, theirs is 23 and 7. So I'm going to put 23 here and 7 here. Okay. And then what I'm going to do now is I'm going to calculate the natural increase rate. So how do we determine the natural increase rate? We determine the natural increase rate by looking at the natural increase rate or the rate of natural increase. And the way we do that is we do crude birth rate minus crude death rate and divide it by 10. So CBR minus CDR divided by 10 is our formula. Okay, so we're going to come back over here. All right, and we're going to pull up that, we're going to pull up a calculator so that we can do the math on this. So here's our calculator. So 10 minus 7 is 3. So I'm just going to put this information here, okay? I'm just going to write it to the side so that you can see it. You don't have to do this part, but I'm just going to do this so that you can see it. So 10 minus 7 is 3. All right. 20 minus 6. All right, so the birth rate is 20, the death rate is 6. So 20 minus 6 equals 14. Let me give it a little bit more room there. Okay, and this one equals 3. So then we do the next one. 27 minus 4 equals 23. Again, you do not have to do it this way. I'm just doing this way in case you're confused or if this will help you out, okay? So 21 minus 7 equals 14. And then for here, 23 minus 7 equals 16. All right, so here are our numbers. So what we do now is we divide this by 10. So again, the formula here is the crude birth rate minus the crude death rate divided by 10, all right? So we take this number here, this 3, and we divide it by 10. And 3 divided by 10 equals 0.3. So that is what we put here, 0.3. Then we repeat that process for the next one. 14 divided by 10 is 1.4. Okay. 23 divided by 10 is 2.3. Okay, we have 14 again, so we know it's 1.4. And then we have 16, and if you see this pattern, you could probably guess that it's 1.6. Okay, so we have this guess it's 1.6. Just to double check, we can do 23 minus 7 divided by 10, and it's 1.6. So once you have that category, and once you have that done, then you can move on to the doubling time, all right? And the doubling time formula is 70 divided by the natural increase rate. And doubling time is how quickly a country will double its population. So again, we're going to go back to our calculator. We're going to put in 70 and divide by this number here, the 0.3. So we have here that it's going to take 233 years for this country, for China to double. So we're going to put 233 here. Okay, then we're going to clear that out, and we're going to do 70 divided by 1.4 and see what that equals. It's 50. So it's going to take 50 years for this country to double. And because this one right here is the same, then we can just go ahead and put 50 here. So they're both going to be 50. So then we could do the next one, 70 divided by 3, all right, equals, or excuse me, 2.3. 30.4. So we're just going to put 30 here. Just round it up. And then we have 70 divided by 1.6. All right. And that's 43, almost 44. So we're going to round it up. So this is the amount of years it's going to take for the population in these countries to double. So we can see that it's the better off their natural increase rate is, the longer they have before they double. The higher it is, the shorter they have in time before they double, okay? Now we're gonna look back over here, and I'm gonna change this to Belgium. All right, so I'm getting rid of Portugal, I'm changing it to Belgium. So we've got Finland, Greece, Belgium, Hungary, and we're gonna look at those European countries and see how their crude birth rate compares. So we're going to head up back over here. So we're going to look at these European countries and see how their crude birth rate appears. So we're going to pull up that document again, and we're going to type in Finland. And we're going to find Finland. And we have here Finland's birth rate and death rate are 8 and 10. So if we do the math, 8 minus 10, we get -2. So they have more people dying than being born. So then we're going to put in Greece. Okay. And here we have Greece. And Greece has 8 people being born, 11 dying. So 8 and 11. So if you want to do the math, if that's something that helps you to see it, you don't have to do this part. This is just if it helps you see it. Then it would be -3. All right. So then we're going to do Belgium. So we're going to type Belgium in here. Again, you get this box by clicking Control F. Belgium is 10 and 10. So they have the exact same birth rates and death rates. They have 0 population growth, okay, because they equal 0. 10 minus 10 is 0. So then we look at Hungary. And Hungary is at 9 and 13. So 9 here, 13 here. 9 minus 13 equals 4. So they have 4. So now we're going to look over at their natural increase rate. So again, we take our calculator and we say 2, -2, right? So we have this crude birth rate minus crude death rate. So we have 2 that's negative, right? So -2, 2 negative, divided by 10. All right, and what does that equal? -0.2. All right, and we repeat that process. 3, -3, right? Divided by 10 is -0.3. All right, then we repeat that process. 10 minus 10 is 0. 0 divided by anything is 0. So we know that this is 0 for the natural increase rate. That's ideal. And then we have 4 negative, right? This is -4. Sorry, that should have been negative that whole time. -4 divided by 10. And so we have -0.4. So what this means is anytime you have a negative natural increase rate, so these 3, right? I'm going to go ahead and change the color for those so that you can see the difference. So I'm going to, all right, so we're going to make this a different color. We're going to make it red because it's special. We're going to bold it. All right. And then we're going to make this one a different color for the same reason. We're going to make it red and we're going to bold it. So these are in the negative. So when you're looking at the totals, you might put in 70, right? Divided by -0.2. Okay, 70 divided by -0.2. And you're going to get this number, -350. Well, when you have a -350, and we're talking about years to take to double, any negative means you're going backwards in time. And since we can't go backwards in time to double things, then what you put here is it doesn't double because it's in decline. So this country's population is in decline. They have a negative natural increase rate. So it will not double right now. It's just getting smaller and smaller and smaller, okay? So we also know that this one is a negative and it's also in decline. So then we put in decline. Again, if it's negative, it can't double, so it's in decline. So then 0.4, okay, that one's in decline as well. Now this one right here, Belgium is a little extra special, so I'm going to make this a little extra special too. I'm going to make it blue. All right, I'm going to bold it. So when it's 0, that means that this country has 0 population growth, okay? It is stable. So right now it's not going to double. It's not going to change. They have replacement rate and they are stable. So that was what we would put here, ZPG and stable. All right, so now that you have this piece, you should be able to fill out the rest of this section. All right, so you do the exact same thing we did here. If it helps you to do the calculations on the side, you can. And then just remember that it's this number divided by 10 to get this number. When you get down to the questions, it says, why do you think some countries are doubling much more rapidly than others? All right, so then you're going to look back and figure out why. And this has to do with your development and demographic transition model. Okay, why do you think some countries have reached negative population growth? It's development and demographic transition. Which figures differ the most greatly between birth rates and death rates? So to answer this one, you're going to find the highest birth rate and subtract it and subtract the lowest birth rate. Okay, so high CBR minus lowest CBR equals the difference, all right, between crude birth rates. Then you're going to find the highest death rate and subtract the lowest death rate. All right, so high CDR minus low CDR, and get the difference between the crude death rates. All right, so then you're going to ask which one is bigger, which one is the greater number. So which one of these right here is greater, that's going to be your answer to number 3. All right. So number 4, how would you explain the disparity, the difference between these two sections here? So why would this one be different than this one? And then you would explain it. And this has to do with development and ETM again. So why might the death rates be relatively low? Why might the death rates be relatively low in many of the countries with high birth rates? So talk about death rates versus birth rates. This has to do with demographic transition model. All right, and then for 6, if you were a national leader in a country with high birth rates, what would you do? So then this has to do with pro and anti-natalism. So take a look back at your notes on that. And then the last question is the same as before, except the opposite. So instead of a high birth rate, it's a high death rate. So, or it's a low birth rate rather, okay? So then you have pro and anti-natalism again. I hope this helps you in understanding how to do the project. If you still need some extra help, let me know. You know for sure that these numbers are accurate, so you can start there. And again, you do not need to put the math here for crude birth rate minus crude death rate unless it helps you. Have a great day, night, whenever you're watching this, and I'll see you in class.